Okay, today is Algebra 2, Section 2.1, Relations and Functions. We're going to do something a little different than we've done so far in the videos. I want you to pause the video right now where you can see these words, and I want you to define all of them in your notes before you push play. I'm not going to be writing the definitions out for you. I'm going to just talk about them, and I want you to already have the definitions written down before you start. So go ahead and do that now, and then once you're finished with that, push play again. So when you found your definitions, you found out that a function is a relation in which each element of the domain is paired with exactly one element in the range. And we'll talk about domain and range in a second. Let's just go through the definitions for a minute. One-to-one in the definition read, each element of the domain pairs to exactly one unique element of the range. On two function, each element of the range corresponds to an element of the domain. Domain is your x values and range is your y values. That's something that's very important. So if you don't remember that from Algebra 1, definitely need to get that down. Domain is x values and range is your y values. So let's talk about some stuff for a second. Let's determine if I give you these problems, so go ahead and write them down with me. Okay, so this is a relation here, and we want to determine the domain, the range, if it's a function, and if it's one-to-one. So the first thing, let's determine the domain. Your domain are your x values. Now some, depending on what algebra book you have, some books have you put the domain in order from least to greatest. Our book does not. A lot of times I prefer to do that, but our book doesn't. So our domain is just our x values. And remember, when you have a coordinate, it's in the form of x, y. So in the domain you have -6, -5, -3, -1, and 6. Our range are the y values, and putting them in order, you have -9, -7, -1, and 7. So the very first thing you look for it to be a function, your x values cannot repeat. So look through all your x values. You have a -6, you have a -5, a -3, a -1, and a 6. They do not repeat, so this would be a function. So again, to determine if something's a function, your x values cannot repeat for it to be a function. Now there's also another way for you to determine if something is a function or not, and that is by looking at its graph. So if you're looking at the graph of something, we have, let's go ahead and graph y equals x squared plus 1. And this is a great time to learn how to use your graphing calculator. So if you go to the y equals menu on the graphing calculator, make sure you always remember to clear it before you start typing anything in, and you hit x squared plus 1 and then hit the graph button. The variable x that you're going to type in your calculator is right underneath the mode button. And so if you look at it, you can also look at the table if you hit second graph, and so it tells us it has a value at 1, 2, 2, 5. If we go the other way, it's at 0, 1, -1, 2, and 2, 5. We have a good quadratic function here. Okay. And so to determine if it's a function by looking at the graph, it has to pass what's called the vertical line test. And the vertical line test means no vertical line that you put down on this paper can touch it more than once. If it touches it more than once, it's not a function. To be a function, your pencil only has to touch it one time. So if you start drawing vertical lines down through this, and the vertical line lands on it more than one time, it is not a function. So in this case, this quadratic graph is a function because you can't draw a vertical line and it touch it in more than one point. Okay. So if we do a different graph, and I'm just going to draw some shapes up here. For example, if you had this graph, it fails the vertical line test, and that's not a very straight vertical line for me here, because it would fail it in 3 spots because it touches it more than one time. So that one would not pass the vertical line test. If you have a line that's been graphed vertically, it also fails the vertical line test, because if I did the vertical line test, it would touch it at every single spot. So that one would also fail. When you looked up your definitions, you looked up the definition of independent variable and dependent variable. Independent variable, I hope you found out, was your domain, and which means your x values. And your dependent variable is your range, which is also your y values. And this is kind of a catchy phrase. Y depends on x. X is your independent variable, and y is your dependent variable because it depends on x. Let's start solving some problems with function notation. You also did function notation in Algebra 1. Function notation means that they put an f of x instead of the y. F of x and y are going to be the same thing. This is just in function notation. So if I say that f of x is equal to 2x squared minus 8, that's the same thing as me saying y is equal to 2x squared minus 8. Just a different notation. So if I say that I want you to evaluate this function at 6, that means everywhere there was an x, so if you see there's an x here and I replace it with 6, everywhere in the function, replace that x with a 6. So I have 6 squared minus 8. So you use your order of operations. There's nothing inside parentheses to do. So next thing you would do is exponents. So we've done our 6 squared and got 36. Now we're going to do multiplication. And then lastly solve our problem. So we get 64. So our function evaluated at 6 is 64. Let's do another problem using this exact same function. So if I can say evaluate this function at 2y, that means everywhere there is an x in the function, now replace it with a 2y. So I have 2 parentheses 2y squared. No, I don't. Remember I told you those parentheses were important. 2y parentheses squared minus 8. So again, there's nothing inside parentheses to do, but there is something for my exponents. So I still have this 2. This 2 squared is 4. Y to the first power squared is y squared minus 8. So you have 2 times 4, which is 8. These two are not like terms, so that would be my answer. The function evaluated at 2y is equal to 8y squared minus 8. Let's switch functions for our next example. G of x is equal to 0.5x squared minus 5x plus 3.5. I want you to evaluate this function at 2.8. Go ahead and pause the video, solve it, and then push play once you're finished. Okay, let's go on here. Hopefully you finished and you got the right answer. So we have 0.5 and we're putting 2.8 in parentheses squared minus 5 times 2.8 plus 3.5. Now, since you guys are Algebra 2 students, I'm hoping that you're to the point where you could type this entire thing into one of the graphing calculators or one of the blue calculators on the stand and get your answer. If not, if you're not to that point, keep using your order of operations and you will eventually get there. So if you type this into your calculator, you should type in 0.5 parenthesis 2.8 squared minus 5 parenthesis 2.8 parenthesis plus 3.5. You would type it in exactly how it looks there. I'm going to do that now. And I get an answer of negative 6.58. Now let's verify it by doing it the long way just to make sure. So I would take my 2.8 and I would square it. So I would have 0.5 times 7.84 minus, I'm going to multiply that 5 by 2.8 and I get 14 plus 3.5. Do our multiplication here. $3.92. When I type all of that in, I get negative 6.58. So again, doing it the long way or typing it all into your calculator gets you the same answer. Now some of you are probably thinking, why does she want me to type it in my calculator? And we're to the point in Algebra 2 that you should be able to do this easily. The only part that I should be worried about with you is the process of plugging this in with the function notation. Okay, let's do another problem. And let's include some letters with this one. Okay. And so I want you to use this function notation with g evaluated at 4a. So everywhere there's an x, we're now going to put 4a. So 0.5 times 4a squared minus 5 times 4a plus 3.5. So this one you are going to have to do the long way because it has that variable in it. So you say 4 squared, so we have 16, a squared, and that's our only exponent. There's nothing inside parentheses to do. So now we can go and we can multiply. We can multiply 0.5 times 16, or what's half of 16. We have 8a squared. Remember, you can multiply and divide things that are not like terms, but you cannot add and subtract them. Minus 20a plus 3.5. None of these are like terms, so that has to be our answer. We can't go any farther. So you would circle it at that point. This concludes section 2.1.